So question number one, if you see, it's asking about the monomer used for synthesis of cellulose. So building block or the monomer for cellulose is glucose. Okay. So basically glucose is basically produced during photosynthesis. Okay. If you talk about in plants, photosynthesis, and that glucose will are used as a monomers for cellulose. So answer is D. Now, second question is actually directly related to Maxwell model. Okay, that is the creep experiment. If you see, so if you see the creep experiment, you have one spring with one dashpot, and the constants are elastic modulus and eta. If you see the equations, your total strain is strain from both series spring and dashpot, and this equation is well known. Okay, now here if you see, it is the same equation that is given in the option. The only thing is notation is changed, like the epsilon is given by E, and the stress sigma is given by S, and G is the modulus. E is given in terms of G, and eta is eta. So this is S, this S, and this E. So E equals to SYE plus SY eta into T. Right. So that means, that clearly means that your answer is what? C. Okay. E equals to S by C plus S by eta into T. The next question. This is basically, if you see, the crosslinked polymer is given and its monomer is getting asked. So your the monomer, I mean, this structure is typically a structure for crosslinked melamine formaldehyde. So to get melamine formaldehyde polymer, you need melamine plus formaldehyde. If you heat, you will get a resin intermediate or pre-polymer, and later on using cross-linking will achieve this structure. So answer is C. Now this question was very what do you call it, confusing, and there's high chance that many of you will might have done mistake here. The reason is the definition, the clarity of definition. So let me tell you the answer. The answer could be shocking for you. I'm really sorry if you're feeling that I have done mistake, but it's okay. Why is this answer A should be right? Okay. So answer A, if you see, what is the question here? Question is, you want to match your metering zone, compression zone, feed zone, and working zone. By default, by seeing the feed zone, you know it receives the charges. R is 2. So see, anyway, this is not going to be your answer. But you see, most of them have R equals to 2. R matches with 2. Okay. Now, if you see, normally what we see, compression zone, it will compress. So we may have feeling that it will induce very high shear forces and effective mixing. But if you see the key function very carefully, it tells in 3, like melts the charge or feed through heat conducted by heating element. So this function should be only where heating element is present, so that heat will be conducted through heating element to melt the charge. And if you see this structure of this extruder, so if you see your heater band or heating element is added in compression zone. So basically the function of compression zone is to basically melt the charge, okay, or feed, and by conducting the heat getting from heating elements. So this compression zone is not going to be high shear because heating element is present in compression zone. So compression zone will be having function of something related to heating zone. So Q will be 3. Okay. So only one option is having Q will be 3. Now T equals to 4. Of course, you know, metering zone will have fully developed a homogenized melt. So it will be basically ready to flow. Okay. And your feed zone is R2. So P4. And working zone. The actual definition of working zone is that it will give you high shear forces for effective mixing. Okay. So this was a little bit tricky questions, and if one doesn't remember like where heating element is present, it's very easy to fall for this trap, like compression zone will give you high shear, but actually The working zone is quite new concept. It is not commonly used in books, but it is there. Working zone means it's a part of the section of your extruder where high shear forces is applied. Okay, so now the question number 115, if you see, it's very interesting question. It's telling like normally if you want to increase polymer wetting, what is wetting? It's hygroscopic nature. Okay, you can add the fillers which have functional groups. Okay, so the functional group will help you to build hydrogen bonding with something wetting agent, or let's say water. Okay, so by reading this strategy, okay, in a typical case, someone used natural clay, and you know natural clay has by default hydroxyl group, and you compound it with the nylon 6. Of course, we have one antioxidant also. Now the resulting composite exhibited very poor property, but that should not be. The nylon, you remember, nylon will, its toughness will increase if wettability is increased, if it absorbs water more, because water acts like a plasticizer for it. Okay, moisture content act like a plasticizer. How you can increase moisture content? By increasing the functional group. Those are ready to bond with water with the hydrogen bonding. Okay, now what might have happened in this case is this natural clay is already having hydroxyl group. You know, hydroxyl group is very much susceptible to form hydrogen bonding with the nylon, because your NH, nylon has NH. Okay, that N can easily form hydrogen bonding. Okay, with the what you call it, you have C11O, so this O can easily form hydrogen bonding with OH. Okay, so the hydroxyl, the OH, I mean the natural clay which has hydroxyl bonds. Okay, so initially when your nylon is there, nylon has some polar group NH and CO, and that will establish hydrogen bonding. Now since this hydroxyl group start bonding with these polar groups available in nylons, okay, there will not be functional group available for wetting. Got the point? And that's the reason. So if you see the structure, if you see here, your natural clay is having by default hydroxyl group. Okay, and if you're adding it with the nylon, normally what does nylon do? Your nylon has CO, that CO attached with H2O with the hydrogen bonding, as you can see here. Okay, similarly your NH also establishes hydrogen bonding with O. Okay, this is what you normally see in your nylon. This is your main chain of nylon, and this is CO and NH groups. This is of course main chain of nylon, and this is H2O, which is actually bonding with the, which is actually bonding between two chain of nylon, and that's why nylon is very hygroscopic, and that is why it is very wettable. If you put it in water, it will become very tough. It will absorb water. But what exactly happening is by adding the clay, natural clay, its property is degraded. The reason is this OH group will replace this H, might have reacted with Cu and NH. Okay, and they covered all the functional groups available, polar groups available in the chain. Now there is no Cu and NH available for H2O, for attaching H2O to the chains, and that is the reason behind. Now this question was straightforward. Okay, so its answer is P, if you know typical TG values. Now this question was quite easy. If you see, its answer is D. The reason is behind. See, your definitely your S is going to have a highest crystallinity. Okay, because see, your P cannot be a crystalline because it is atactic. So this is not going to be an answer. Now Q cannot be, symbiotic polystyrene cannot be having highest crystallinity if you have PET. Okay, the reason is it is symbiotic, and also polystyrene has bulk, even though it has some chain regularity because of symbioticity, it will be some crystalline, but your bulk side phenyl side group will always create problem. So it will never have highest functionality. highest crystallinity. So definitely this Q is not going to be highest. So this option is not answer. Now your answer might be B and D. Now if you see carefully, S is highest. It's saying Q is higher crystallinity in B and R is higher crystallinity in D. It's telling that means nylon is having higher crystallinity, nylon 6 is having higher crystallinity as compared to Q. Now it is debatable. It is debatable. You cannot conclude directly from here. But let's check for other option. It's telling here P has higher crystallinity than R. Means atactic has higher crystallinity. Atactic has higher crystallinity than nylon. That is wrong. This cannot be answered. Your atactic cannot have higher crystallinity than the nylon. Okay. So obviously this T is answer. Even if you have a simple logic, you can easily achieve, go to the answer. Here, this typical question was very directly from Robert Ovele. So it is already, the same graph is already given in the exercise itself. So, for chain growth, okay, at very small conversion, you may get very high molecular weight. That is why, because it is chain growth, okay. In strip growth polymerization, you need to have very high conversion, greater than 95% to get let's say 20 mer or 30 mer, means chain speed 30 or 50 or 100 mers. You need to have very high conversion. Okay, so you need to have very conversion. That's why this is step growth. And for living polymerization, your molecular weight is directly proportional to conversion. It is linearly. So answer is P. And this is how you can use this source also, or you can go in Robert Ovele. Okay. Now this was really interesting, and I really want to tell one thing. Here, from here onward, MSQs is started, and telling you all honestly, okay. This year, the record highest number of MSQs was asked in any subject ever. In any subject, like in other streams also, I've checked it. Highest 7 number of multi-select questions were asked. Even multi-select questions were put in match of the following also type questions. Even in whole X, if you go in all subjects, you'll never get this many MCQs. Maximum multiple select is 1 or 2 or 3 maximum, not 7. And that actually might degrade the marks, okay, a lot. So normally students who will attempt polymer science and material science, they will be scoring polymer science. They will be scoring really low marks. Let's say 5 to 7 marks lower than they have capability to score. So you need not to be worried about at all. Okay, don't need to be have any kind of worrisome, because simply it is going to be normalized. If something from food technology is scoring 30 out of 25, and average score for polymer science is let's say 50 or 20, definitely your marks is going to improve in normalization. That tells, normalization itself tells you, if one of the subject is easier for few people and your subject is harder or difficult or set very poorly or very difficult, then your ranking will be overall. Okay, so it is going to be normalized. If it is not going to be normalized, okay, because your ranking is by XC, okay, so it's not ranking for only polymer, so definitely it's going to be normalized, so you don't need to worry about it. Okay, definitely you'll get benefit in normalization. So let's get here question. So this one MSQs, okay. So fishing rod can be pultrusion because it's a rod. Pultrusion is actually one process for fiber manufacturing. Now bottle you can produce using blow molding. Plastic sheets you can use using compression, as well as sheets you can use your compression molding machine. Okay, let me show you the answer, because here only your plastic trays you can use compression as well as thermoforming. Okay, so you have multiple answer. Your P3 and Q4, okay, and R1 and S2 and T, P3, Q4, R1 and Means trace can be made using compression only. Everything is same. You say it was not difficult. This question was not difficult at least, but later on when the other questions will come, they are slightly difficult or very difficult. Okay, so this is what the answer is. It's a basic common sense. Now this question is also MSQ. Okay, so normally when you know the curing agent that we know, okay, we have idea like it will be either mostly they are sulfur or they will be peroxides. Okay, so your carbon black is used for filler, zinc stearate is used for processability, increasing processability. Okay, there is another curing agent that is very hazardous and toxic. It is not advised, and normally it is replaced by other vulcanizing agent or curing agents. Okay, but it can be used dinitro. Okay, so whether it is dinitro or dicumyl or whatever the dye, that means it will have more than it will have two functionality or more than one functionality. That can give you two hands for cross-linking, right? So that is a common sense. If you have used, you can easily find A and T, even though if you have not memorized this T option. Okay. Because it is MSQ, so definitely one is not going to be answered. Zinc stearate and carbon black has no two functionality, so definitely it cannot be. Definitely your dye is having two nitro group, so definitely you should think for it. Okay, so A and T. Some questions can be solved using common sense, even if you don't remember the answer. Here, this question also can be solved using common sense. For example, see, it's telling lipase is one kind of natural enzyme which cleaves carboxyl ester bonds. Carboxylic ester bonds. Where you will get ester bonds? In esters, polyesters. Okay. Now, identify the polymer which can be degraded, and it's the MSQ. And which one? What are the polyesters? In PP is not polyester, PVDF is not polyester. PET is polyester and PCl is polyester. Okay, and both can be degraded. Both have ester linkage. That means both will be cleaves by enzyme. Both will be degraded by enzyme. Okay, so B and D is option answer. You cannot write only B or only PET. Okay, B and D. This question was also very common sense based, even if you don't remember. The reason is, see, if you simply remember the recipe of Ziegler-Natta catalyst, what does it tell? It tells you you have a halides of titanium, vanadium, zirconium, or yeah, this, and halides means you can add chlorine or some other halogens with them. So see, your titanium chloride and vanadium chloride, this could be the potential answer. Okay, and also you have organometallic, mostly the aluminum organometallic. Means you have organic elements along with non-transition metal like aluminum. Aluminum is more popular one. This A and D is going to be answer. This is not answer. This cannot be. Zinc is not there in the list, and we need this highlights, not oxides. Okay. So A and D. Even if you use common sense, you don't remember. You can find the answer. Answer is A and D, and here is the recipe. So basically, you have a catalyst, which is basically transition metal halides like titanium, vanadium, chromium, zirconium. Okay, and co-catalyst you use basically organic non-transition derivative like aluminum compounds. Okay, alkyl aluminum compounds. Like here we are using meth propute. Here you are using meth propute. Okay, so anyway, this alkyl is same, and we are using here it is aluminum. So A and D. Now, this question was very tricky, and this will come under most difficult category. Okay, this could be the hardest. Few questions are set so easy that you can solve within seconds, within minutes, and few you have to use a lot of brain. And since it is also MSQ, so let's understand one by one. Okay, so what is stress relaxation process during either rubbery or deform or whatever? And what is the long range molecular motion? Whether it happens in what of the resin, it's okay. What is that? What is segmental motion, and where it will, at what temperature it will be there in polymer? Okay, and in which of the reason your deformation is or relaxation time is molecular dependent. So this is if you see what state is seen from when your temperature is greater than melting. So it will be liquid state, okay, and your molecular motion is very large, very large. So here we are going to discuss about the molecular motions. Okay, when your temperature is between Tm and Tg, that means in rubbery state. Okay, so your state is rubbery. That means it is nothing but a super cooled liquid, and motion is also relatively large, up to 50 carbon atoms. When your temperature less than Tg, okay, your material is in glassy state, polymer is in glassy state, and molecular motion will be very small or it will be in frozen. Now here you can relate the molecular motion and the state, whether it is glassy state or rubbery state or the liquid state, whether your temperature is near Tg or temperature is above Tg or temperature is above Tm. Okay, what is the molecular motion and what is the state? Okay, these things is clear from here. Now whether your rubbery state or glass transition region is molecular dependent or not, that is one question that we have to understand. Another is in a glassy state or rubbery state or any state, how deformation will behave, like how once you deform your polymer, all the chains is going to aligned or oriented in certain direction, right? So with the time they are going to relax. How? By increasing their entropy, by removing heat from them. Whatever you have done, whatever by orienting them in the same direction, okay, by applying force, means after deformation you have already oriented, so you have decreased the entropy. It will again try to relax. Why? To increase entropy. Because delta G must be negative or lower. Free energy should be minimized. So delta H minus T delta S. Delta S should be always positive, and entropy should always increase. It will try to relax. Okay. Now see, what about the heat? Heat will be minimized, so that this delta G will be negative. How heat will be minimized? By removing the heat from it. Heat will be dissipated. Like when you stress something, it will become hot. With the time, it become cold. Why? Because its molecular will try to again relax to take greater entropy configuration, and it will dissipate the heat. That is the how with the deformation, how the entropy or relaxation is happening, and how with the so the next thing is, so we learned about the state and the molecular motion in different reason. Now let's understand. So the summary is at Tg, okay, so the Tg is the lowest temperature at which you will get segmental mobility, okay, molecular motion, and lowest temperature at which chain can flow or be processed is at near Tg. Below Tg, it's a frozen. Okay, chains are effectively frozen, and polymer is described as glassy. Motion is restricted to short range vibration and rotation. There is no any only rotation and vibration. Okay, there is no any segmental. And near Tg, you will get segmental mobility. And above Tg, chain possesses enough thermal energy to allow long range and molecular motion. So above Tg means in rubbery state. Okay, if you remember this graph, this is Z, this is temperature. This is okay. Let me draw. If you remember, this is the typical Tg transition. Okay, and this is the rubbery region, a leathery region, right? So above Tg, you'll always get rubbery state, right? So I'm talking about that is the region. Okay, long range molecular motion, chains can be move past each other almost up to 50 chain atoms. Polymer chains are rubbery and can flow as a viscous liquid as processed. So these are the basics that you have to understand to answer that question. Also, how molecular weight, how with the time modulus is going to relax. Okay, or stress is going to relax. That is called stress relaxation. So if you see your typically a Maxwell model tells you this is how your stress is going to relax. Okay, it tells you like sigma equals to sigma naught e to the power minus t by tau. Sigma is E epsilon. So epsilon is always fixed in stress relaxation. So yeah, that means if epsilon is fixed, then how it can become this function must be function of time, because right hand side is function of time. Okay, so I mean you can write E equals to sigma naught by epsilon naught e to minus t by tau, as you can see here. So how it is a function of time, so E of t. That means the modulus will relax with the time, or stress will relax with time. So you can write this graph. If you see, this graph can be written into temperature as well, modulus with temperature. You can always superimpose time with temperature, temperature with time. Both are same thing. Okay, that means your graph will be always similar. You can write here time also, you can write here temperature also, because time temperature can be superimposed. They affect in a similar manner. Like the way your modulus is going to relax with the temperature, similarly your modulus is going to relax, means decreased, with the time as well, as you can see here. Okay, so I hope you understood with the time how it's going to relax. Now we have to understand it, how this relaxation process is affected by molecular weight. Then only you will be able to answer one of the options. So as you can see here, with increase in molecular weight, what's happening with increase in molecular weight? There is no change. If you see all these three curves, 1, 2, 3, and 4, all these 4 curves, all will have all have the same this line. If I will change the color, all is having the same this line. You got my point? What does it signify? All is having the same line here, and from here they are diverting. What does it mean? This is your near TG. Near TG, you see no effect of molecular weight. So near TG, molecular weight will not having any effect of this stress or modulus relaxation with the time. Remember, so it's affected badly in the above TG, in rubbery state. See, with increase in molecular weight, as you can see here, how the flow behavior is changing. It will affect higher molecular weight. You can see will relax. It will take more time to relax. For example, see, this is lower molecular weight. See, the relaxation is happening at this time, T1. If we increase the molecular, see, the relaxation is happening at this time, T2. If we increase the molecular, relaxation is happening at T3. So with increase in molecular weight, the relaxation, this is going to be time or temperature, both is same. Okay, so relaxation time will increase. It has effect. Okay, so this is how you have to understand. With increase in cross-linking, this is how the things are affected. They are affected in all regions, this region also and this region also. Okay, so I hope you all have a typical idea. Okay, so this is glassy region. This is glassy region. This is typical glassy to rubbery transition at TG, and this is typical rubbery state. Okay, this is where you have a molecular weight effect. Okay, this is where you have a rubbery state. Okay, got my point? So you see, it is actually affecting by molecular weight.